Hello everyone, welcome to TriRights, the new era of learning. My name is Sheikh Abdul Rafiq and I am your data science trainer. So let's move into the topic. Today's topic is data science regression table about R squared. Okay, R squared is nothing but it is an adjacent R squared describe how well linear regression model fits on the data point. So let's move into the topic. We need to know about the R squared. Okay, where R squared, also known as the coefficient of the determination, is a key matrix in regression analysis, okay, that measures how well the independent variables explain the variance in the dependent variance, and it range from the 0 to 1. It's optimally considered 0 and 1 as a decimal input in the R squared, okay. If in the case of 0, in the case of R squared is equal to 0, that means the mean independent variable is not explain any variance in the dependent variable. Okay. Uh, do not explain any variance in the dependent variable. Okay. In the case of R squared is equal to 1, means the independent variable perfectly explained the variance. Okay. So it depends the explanation of the rejection models to fit with the analysis. Okay. So in the concept of R squared, we have three types of R squared. We call it as interprediction of R squared. So mostly we have high R squared, low R squared, and moderated R squared. So coming to the point on the high R squared, it's close to the zero, it's close to the one. Okay, in the high R squared, it's close to the one. Means the model explains most the variance in the dependent variable. Okay, so now coming to the low R squared, it's close to the zero. The model explains only some variance, yeah, likely indirectly, poor fit. Okay. Now, may modern R squared. It means data will estimate according to the range of 0.3 to 0.7. In between the points range, it will be measured in the modern R squared. So the model explains some variance. Okay, but mainly need importance. So in the art field, we also discussed about the previous class about the regression. So we discussed about the OLS regression. OLS is nothing but ordinary least square method, right? So here we have coefficient, standard error, t-value, p-value, and after some range in between. So R squared model number and model OLS, dependent variable, independent variable, intercept. So we all know about the concept. Okay. Now see here the value of the R squared is always between the 0 to 1, mostly 0% to 100%. Okay. A R squared value means that the many data points are close to the linear regression function line. So most of the case of R squared, uh, all the data points will arrange into the line equal to the line. Okay, in low R squared, the value that means that a linear regression function lines does not fit on the data well. So like this, the data will represent. Okay, the most of the data will not represent with the according to the line in proper way. So that's the case we call low R squared. So this is high R squared. All the data sets equal to in the range of equal order. So now we want now just I want to create a high R squared and low R squared. Let's move into the VS Code. Okay. Okay. Now let us want to import some features. We all know about the Python libraries like Pandas, NumPy, and SciencePy, Matplotlib. So in that we want to import some features like called for some libraries called Pandas. My keyboard is typing too fast. Okay, I adjust it. Wait. Now import Matplotlib. Import matplotlib.pl plot as plt. Right. Now from SciencePy we need to import stats concept. Okay, we need to import stats. Okay. Now take our data. We know our data, how to represent the data in CSV form. So reach CSV, my data was located in the path of, this is our data, right? Health data, duration, average pulse, max pulse, calories per night, hours work, and hours sleep. So consider this data into R squared. H does equal to 0 and hours. Okay. Now we need to x equal to, for x we consider as first, I want to showing that you high R squared. So from high score R squared, we need to represent the data in order. Okay, in order and proper manner with the points. So let's take the average pulse from the data set. So here I mentioned health data. Right, I didn't assign any variable to the PD. So assign a variable like health data equals to. So from here x I assigning health data. In health data I considering average pulse. Okay, same to the y. So same to the y I am assigning has calories burnage. Okay, from my health data set. So this type we can see how the data is far from the table. So here we can consider like this calories burned. So after that we need to some import some stats like now we can see here coefficient, standard error, t value, p value. So both this all need we need to import here like a slope. I need a slope and I need intercept. Uh, Nothing but this all as a variable. I am considering as a variable, not as an a all this variable I'm assigning to the output of the stats. Okay. Now this is the functions. I just assigning as a variables. I assign this to stats linear regression. Okay. So from that after that I need to R, I need to p value, and after that I need to std stats error. Okay. This all I'm assigning to the stats model. Stats dot mean regression is a function. I'm assigning the values x comma y. Okay. Now we use now here Python function to determine the way actual slope function. Okay, we all know the linear function equation, right? Uh, like near slope into x plus intercept, right? In case we called as in terms of c ax plus b or c equal to ax plus b, like that. So we take consider here a function called my function of x. So for that I am returning here same the equation of linear equation of slope into x plus intercept. Okay. I'm creating a model called my model. I'm creating my model where it has a variable. Or from it, I'm using list concept for mapping the data, for mapping the my function data to my function data and for x. Okay, here I'm mapping the data. After that, I want to print my model. Yeah, I want to print not my function, print my model. Okay. So now after that, we want to plot the data. Okay. We use now we want to plot the data. Okay. For PLT, I'm using uh, scatter for X and Y, right? Okay. From X and Y, I want to plot. I need to assign a plot for whom X and my function, right? Equation is in my function, right? For X and no, not my more. Okay. No. For X and my model. Okay, here my model is listing the map, and for this, and I am assigning the my model and X. I am assigning here plotting. For after that, take a Y lim. Y lim means Y min equal to 0 and Y max equal to, I am assigning the range of 2000 like that. Okay, here Y X lim equal to X min equal to 0 and X max equal to 200. Just I'm assigning 200. After that, I need to enter the pivot X label. From X label, I am assigning from X label I am assigning here average pulse. Okay, and for that Y label, I am assigning here calories burned. So this is my data, right? From this data, I need to consider a R squared, highly R squared method. Okay, from this we use PLT show for the showing the graph, right? We use the PLT show function. Now my code is run. So okay, run the code. Okay, wait. Wait a second. Excel health data average pulse. Okay, wait. The data from object is not callable. Wait a second. I did any mistake in the code. So here we did a mistake of spelling mistakes. Okay, it is not. Now it is set. Now run. Now data is run happily. Now see the data here. We can see a linear line and with the adjacent of same order, if the adjacent data with R squared, it is a linear function, right? Here we all read about the high level data. See, a high R squared value means that many data points are close to the linear regression function line, okay, or in between line. So this is high R squared. So assign. So in case also we can see that if I take another variable like if I take duration, like unordered set data, I want to consider like here a duration. Now I want to show you low level, low R squared data set, right? From this, I considering X has okay, wait. Here I considering duration. Okay, from duration, here I changing my X value instead of average pulse. Oh my, what happened to my keyboard? Wait a second. Okay, now it will be a work. Okay, I'm changing my duration and I'm changing my X value both here. Now, now run the code. Okay, now we can see here our data will running. Now see, this is also called a little bit. Wait, I am zooming clearly for it. I'm zooming it. Okay, now it is also called sum between of a high output data because few data is far away, not the too far, but little bit it far away from the data. We can call also a high level. So I want to present, low level, right? For the low level, I consider has hours of sleep, okay, to calories burnage. Instead of this, I changing my data for calories burnage has hours of sleep, okay. Now see the code. Now see the graph. Oh, getting straight line. Wait a second. Just I want to change it. So I am changing just as only x value I am changing, not for y. Just wait. Okay, I am trying to show you that low R squared value graph. Okay, that's why I'm trying. Okay, now here see, we can observe the low level data here clarity. We didn't assign any lines, so see, the data is how far to the lines. So like the example like this, data is some between oh we can come we had some less data, so that way we didn't getting the proper graph like this. We have few data. Okay, if we have the huge data, it can be considered as like this. So the order of the data is like this. Okay, after crossing the line to the data. Okay. Okay. From this, in the concept of R squared, we also had a concept of adjacent R square. So it is nothing but there is a problem with R squared. If we have more than one explanatory variable, R squared will almost always increase if we added more variables, okay? And will never decrease. If we in constant it added a value and it will never decreases, right? This is because we are adding the more data points around the linear regression function. If we added random variables, that does not affect calories burnage, okay? We risk to falsely conclude that the linear regression function is a good fit, okay? Adjacent R square adjust for those problems. Uh, it is therefore better to look at the adjusted R square value if we have more than one exploratory variable. Like here we can see their data. We have the both models here, adjacent R square model and R squared models, right? We can see the both of the data. So here the adjacent R square is 0.814. The value of R squared is always between the 0 to 1. It considers either 0 or either 1. Okay. High R squared means that the many data points you also know about this. So let's take a data complement like here I want to create this data R squared like I already created here for the R squared data. So like we also previously see this code. I'm changing just the add duration. That's it. Now see this. See here. We know our adjacent R squared is one and and R squared is also one. Okay. The intercept is 80 and our model is OLS. Okay. Average pulse is 2. Like the model concept, we can introduce. So here the value is 1. So 1 means we can consider the high R squared. Okay. So I hope you understand, guys.